All right, let's talk about the magic behind the real-time web. Today, we are diving deep into WebSocket APIs on Amazon API Gateway. If you've ever used a chat app or a live dashboard and wondered how it all works so seamlessly without you hitting refresh, well, you are in exactly the right place. Let's get into it. So, first, let's just set the stage. For the longest time, the web has basically run on the REST model. It's simple. A client asks for something, the server gives an answer, and that's it. Conversation over. It's like ordering at a fast food counter. But WebSockets, they're totally different. The connection stays open, creating this persistent two-way conversation where either side, the client or the server, can just start talking whenever they have something to say. And that right there leads to the big question. In this serverless world, where we're all about thinking stateless, 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 how in the world does something like API Gateway manage these long-lived, stateful connections and make sure every message gets exactly where it needs to go? To figure that out, here's how we're going to break it down. First, we'll get into why we even need to go beyond that classic request-response model. Then, we'll really dig into the mechanics, how these APIs work, how they manage connections, and how they send messages back. And finally, we'll tie it all together and see how you take this from just an idea to a real working thing. Okay, first up, moving beyond request response. The whole reason this technology exists is because we demand instant, real-time interaction now. The old way of constantly asking a server, hey, got anything new? Anything now? How about now? That process called polling, it's just super inefficient and slow. WebSockets totally fix this by just keeping the line open, ready for data to get pushed the second it's ready. And you see the power of this all over the place. I mean, think about any chat app where messages just appear instantly, or a collaboration tool where you see someone else typing in real time, or even a stock trading platform where those prices are updating in the blink of an eye. All of those experiences, they're made possible because of that persistent two-way street that WebSockets provide. All right, section 2. Let's get into the core mechanics. This is where the real magic happens. How does API Gateway see a message come in from a client and know exactly which piece of your backend code, say a Lambda function, is supposed to handle it? The very first piece of the puzzle is something called the route selection expression. You set this up once for your whole API, and it's basically just a simple rule. You're telling API Gateway, hey, for every single message that comes through, I want you to peek inside the JSON and look at this specific field. A super common one is to look for a field called action. So once API Gateway looks at that action field you told it about, it finds a value. And that value, that's the route key. So if the expression is the question, what's the action, then the route key is the answer that points to the final destination. Each possible answer, each route key, is then mapped to a specific backend integration. Now this is where it all clicks. Look at this simple routing table. Our expression is set to look at the action property. So if a client sends a message that looks like database join room, API Gateway sees the value join room, looks it up in the table, and bam, it invokes the join room lambda. If the action is send message, it sends it off to the send message lambda. It's really that simple and incredibly powerful. Okay, so routing messages makes sense, but what about the connection itself? Well, in section 3, we're going to see how API Gateway uses 3 special predefined routes to manage the entire life of a connection, from the moment a client shows up to the moment they leave. It all begins with .connect. When a client first tries to open a WebSocket, this route gets triggered. Think of it like the bouncer at the door. This is where you handle all your authentication and decide if this connection is even allowed in. Once they're connected, all your custom routes, like our send message route, are in play. And then finally, when the connection is closed for any reason, the .disconnect route is called. This is the perfect spot for cleanup, like maybe removing a user's status from a database. But what if a message comes in that doesn't match any of your custom routes? Or what if it's not even valid JSON to begin with? Well, that's exactly what the $default route is for. It's your catch-all, your safety net, making sure that you can handle unexpected stuff gracefully without the whole thing breaking. Now for section 4. And honestly, this is the part that makes WebSockets so powerful. We've talked a lot about the client sending messages to the server, but how does the server turn around and start a conversation, sending a message back to the client? The answer is this really elegant callback URL that API Gateway gives you. See, every single client that connects gets its own unique connection ID. Your backend code, like your Lambda function, can then just make a simple POST request to this special @connections endpoint, telling it which connection ID you want to talk to. And that's it. That's how you push data back to a specific user, fulfilling that promise of true two-way communication. Okay, last section, let's bring it all home. We've gone over all the core concepts. Now let's look at what the actual practical life cycle of building and managing one of these APIs and API gateway looks like. It really just boils down to a four-phase cycle. First, you develop it. You define your routes, hook up your integrations. Then you publish it by deploying it to a stage which makes it live and callable. Of course, you absolutely have to protect it, which is critical. And finally, you monitor it, keeping an eye on its performance and health with tools like CloudWatch. And here's a super important point on security. You don't have to authorize every single message that flies back and forth. Because the connection is stateful, you do all your heavy lifting for authorization just once, right at the beginning on that $connect route. If they pass the check there, the entire session is considered secure. Now, here's a key operational detail to keep in your back pocket. These connections don't last forever. API Gateway has a hard maximum connection lifetime of 2 hours. And that isn't just some random number. It's a core design choice that helps manage resources efficiently in a serverless world. It prevents connections from going stale, so your client application just needs to be ready to reconnect if it needs to. And one more thing, and trust me, this one catches a lot of developers. If you add a new route, or you change a backend integration, or you tweak pretty much anything about your API's configuration, those changes are not live. Not until you explicitly redeploy the API to its stage. Don't forget that step. So to wrap it all up, what API Gateway gives you for WebSockets is this fully managed, completely serverless foundation. It handles all the messy stuff, the connection management, the scaling, the routing, so that you can just focus on building the cool business logic for your real-time application. It's an incredibly powerful tool for building the kind of interactive web we all expect today. Which really just leaves one question. What amazing real-time experience are you going to build next?